Welcome to Algebra 2 Unit 7's video for skill number 64. I can translate between exponential and logarithmic expressions and use this to evaluate logarithmic expressions. We'll begin our notes on page 64A. Logarithmic functions and exponential functions are inverse functions. And I've shown an example here that shows that log base b of a is equal to x if and only b of x, or b to the x equals a. So we're able to translate between these two forms with, let's see, our base there and there. Our exponent is the answer of the log, or the exponent of the exponential expression, and our answer of the exponential expression is what we're taking the logarithm of. So I've provided a couple examples below. Log base 2 of 64 is equal to 6. In other words, 2 to the 6th is equal to 64. So on the skill test, we'll work both ways with this. We might be given an exponential expression and have to write it as a logarithmic expression, or we could be given a logarithmic expression and be asked to write it as an exponential. Log base 2 of 8 is equal to 3. This means our base of 2 raised to the third power is equal to 8. Another example may be what we would have log base 3 of 81. And you're supposed to use mental math to evaluate that. So the way we would do that is we'd say, what is this equal to? Because that's what we're trying to find. And we could rewrite it as an exponential expression, which would be 3 to the x equals 81. And from there we would go through our math process of figuring out what that x value is. So 3 to the 1 is 3. 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81. So our answer is 4. It should be noted that if no base is written, it's assumed to be base 10. So log of 1000 equals x means base 10 raised to the x power is 1000. And in that case, x would be 3, because 10 to the third is 1000. Alright, and on the next page. Alright, so we have two special properties of logarithms. The first being log base b of b equals 1. And that makes sense. If we were to rewrite this one as an exponential expression, we would have b to the 1 is equal to b, and that's a true statement. So we can take it and say log base 7 of 7 is equal to 1, or the examples I showed, log base 5 of 5 is equal to 1, log base 10 of 10 is equal to 1. Notice the 10 is missing, because if it's missing we assume it to be a 10. The next special property of logarithm is log base anything of 1 is always equal to 0. So if we do log base 6 of 1, that always will equal 0, because 6 to the 0 equals 1, 4 to the 0 equals 1, 10 to the 0 equals 1. So for the skill test, we need to be able to translate between logarithms to exponential expressions. Like on the previous page, we should be able to apply these special properties and then finally evaluate using mental math. So that we're given 1/2 of an equation and we're supposed to evaluate it. So here log 100 means log base 10 of 100, which means 10 to the what equals 100, and we're trying to solve for that value. 10 squared is 100. I'll leave these two examples for you to work through yourself. Alright, the key ideas and concepts for this section are being able to translate from an exponential to a logarithm. So if I gave you 3 to the third equals 27, you should be able to translate that to log base 3 of 27 equals 3. We should also be able to work backwards, so if I said log base 5 of 125 equals 3, you would be able to translate that to 5 to the third equals 125. Finally, we should be able to evaluate expressions using mental math. So the way I'd describe that is if I just told you evaluate log base 5 of 125, you should be able to go through the process of realizing that that is in fact equal to 3. We should keep in mind that there's a few simple or special properties of logarithms, the first being log base 5 of 5 is equal to 1, or basically log base b of b equals 1, and then the other special one is log base b of 1 is always equal to 0. All right, thank you.